Welcome to our reflex block lesson. So we already learned all about our muscles and our bones. So why exactly do we care about our reflexes? Well, jumping right into this, our reflexes are known as inherent motor responses to specific sensory stimuli, and they play a critical role in assessing neurological function, and they can be integral in identifying alterations or impairments in our neural pathways or our neurological status. So we're gonna start with our leg right here, and we're gonna focus on these two key muscle groups. And this first one here is this bicep femoris and our quadricep femoris. So these muscles are really important for our leg stability and our leg movement. And this quad right here is going to be really important because of what we're about to do to it. On top of our knee right here is this patellar tendon, and this connects the quadricep femoris to the shin bone. So this tendon is going to be the target where we're going to use this reflex hammer. And this is a tool that we have seen in lesson 1. So we're going to tap this reflex hammer below the bony prominence of the patella bone, which is right here below the kneecap. When the reflex hammer strikes this patellar tendon, it's going to initiate something known as the knee jerk response. So this is going to set off a sequence of events that happens as soon as this little hammer strikes the knee. So the response is going to start with our stretch receptors in our muscle. And that sudden tap is going to stretch the tendon and consequently this muscle up here, which activates these stretch receptors. So these receptors are going to send signals through the sensory neurons and to our spinal cord. But each sensory neuron has a cell body that's located in the dorsal root ganglion, which is a cluster of nerve cell bodies just outside of the spinal cord. Once the sensory signal reaches the spinal cord, it's going to enter into the gray matter. And this contains cell bodies of interneurons and motor neurons. So these interneurons are going to process the sensory information and they're going to quickly relay a response. This response is going to go to these motor neurons through the white matter. And the white matter consists of bundles of nerve fibers. So these fibers are going to then transmit signals back to the muscles. And the motor signals finally reach this bicep femoris and the quadricep femoris, and it's going to cause them to contract. So this contraction is what you see that is known as that reflex response. So all of this is done in milliseconds. So we're gonna see that patellar tendon stretch, which is gonna stretch the muscle inside of our thigh, and it's gonna send that through our sensory neurons to the spinal cord, where it's doing kind of a little bit of mixing of signals here, hitting those motor neurons that's coming back to the muscle to be like, hey, go ahead and kick out. This is something that we don't have control of on a good day. And if there is something going on neurologically, or there's something maybe going on with our neurons, so if we have some kind of spinal cord injury or we have stretch injury to these neurons, which if we remember from our neurological chapters or lessons, that would be a diffuse axonal injury. That could also be something that would prevent us from seeing reflexes like this. So in traumas, this is a big reason why we test for all kinds of reflexes to make sure that all of them are responding appropriately. This concludes our reflex block arc. Although very short, it is sweet and to the point. I will see you in the next one, all about our cranial nerves.